So hello everyone and welcome back to a brand new video, and in this video I'll be solving problem A, that is no majority, from Atcoder Grand Contest 60. And this problem is quite similar to a problem that we solved from the last Atcoder beginner contest, that was don't isolate elements. So I will recommend you guys to solve that problem first, and then you will be able to see the similarity in both the problems, right? Anyway, let's move on to the solution and see how we can solve this. But before we move on to the solution, I want to tell you guys about Newton School's coding contest. As you guys know, Newton Schools does this coding contest every month. And this month, the name of the contest is Code Rush X, and the prizes are better than ever before. So you can win prizes up to rupees 10 lakhs. And along with this, you can win placement opportunities in top product companies. So like if you guys want to play this for fun or you guys want to play this for placements, that is totally up to you. The contest will be on 28th of January. It will start around 9 p.m. and the contest will be 3 hours long. So there will be ample amount of time for you guys to brainstorm and solve good quality problems. So if you guys want to benchmark yourself or just win some placements, this is a very good opportunity. I will leave a link to this contest in the comments and in the description, so you guys can go and sign up from there and show, or you can flex how good you are at problem solving. So now let's move on to the solution. So in the problem, we have been given a string of size n, where your size n can go up to 5000, right? So something like s1, s2, s3, so on up to sn, right? All of these si are either lowercase English alphabets that are from A to Z, or either your si will be a question mark, right? So you have been given a string that consists of lowercase English letters and question marks. Now you have to find the number of ways that there are to replace the question marks such that there is no sub-array with a majority. Now what do we mean by majority? It means that if we, let's say, have a sub-array from SL, SL plus 1, so on up to SR, right? Let's say this is a sub-array. Size of this sub-array is R minus L plus 1. So if there is some element, right? If there is some element whose frequency is greater than R minus L plus 1 by 2, that is in some subarray, if some element is occurring more than size by 2 times, then we say that that subarray is in a majority. We can say that this subarray is in a majority if there is some element whose frequency is greater than size by 2 of this subarray. So you have to find the number of ways or number of strings that you can form after replacing the question marks such that no subarray in this string S has a majority. So that is the problem. Find the number of ways to replace question marks such that no subarray in S has a majority. So that is the problem. Now how can we solve this? So let's first try to analyze the complexity of this problem, and then we can see like which approach do we want to take to solve this, right? So let's move on to the solution, right? So we can replace any question mark with 26 different letters, right? We have A, B, C, so on up to Z. So for every question mark, we have 26 different options. And your string can contain up to n of these question marks, right? So in total, we can say that the total number of combinations will be 26 into 26 into 26, so on into 26 up to n times, right? Because your string can contain n question marks, and for every question mark, we can have 26 different possibilities. So in total, my time complexity can go up to 26 to the power n, which is a very large number, right? Considering your n is equal to 5000, your 26 to the power n is a very large number. So there is no way that you can iterate over these many combinations. So how do we optimize this? So I explained this in my last video, that is in don't isolate elements, how we can use DP to solve this, right? So like if we have exponential complexity, here we have O of 26 to the power n, right? This is exponential complexity. Then we can use DP to convert this from exponential to linear, right? We can make this O of n, which is linear. But there is a condition here, that is your dp of I, right? Your dp of I should only be dependent on some constant number of states, Like if you guys see the previous video, in that video your dp of I was only depending on dp of I minus 1, right? So if your dp of I is only depending on a constant, that is a very few number of dp states, then we can use dp to go from exponential complexity to linear complexity. Now how can we do this in the following problem? Let's see that now. So if you try to like make a string, let's say we have a and a question mark and a question mark and a question mark and a question mark and a question mark. Now what can we place at this question mark, right? If you try to place a here, we will get a question mark question mark question mark question mark, right? Whatever. But if you see this substring now, right, here frequency of a is equal to 2, right? And 2 is obviously greater than 2 by 2, right? 2 is greater than 1. So like if you see this subarray, in this subarray or in this substring, your a is in majority. So this will not work. So we cannot place a here. So we have to place something from b up to z. So let's say we place x here, right? Let's say we remove this and we place x here. Now let's move on to the next question mark, right? So what can we place here now? So again, if you try to place a here, let's say we place a here again, then we will get something like axa question mark question mark question mark, so on up to here. So again, if you see this substring, right, size of this is 3, so 3 by 2 is equal to 1. But if you see frequency of a is 2, which is more than 1, right? So again, this substring is in majority. So you cannot place a here. Similarly, if you try to place x, right, here, you will see the same thing, right? You will get a x. Again, this xx is in majority, so you cannot place x here also. So you can place here anything from b, c, d up to z, but not a and x. So you are able to see the pattern, right? So if you are at some like letter si, you cannot place si minus 1 here, and you cannot place si minus 2 here. But let's say we place b here, so we get axb, right? So now let's try to see for this question mark, right? If you try to place a here, let's say we place a here, so we get axba. So now if you check, you will see that there is no majority. So we can place, like if we have si, we can place like symbol at si minus 3, but we cannot place symbols at si minus 2 and si minus 1. If you try to place symbols from si minus 2 si minus 1 at si, it will create a majority. So you cannot do this. For symbols that are on the left side of si minus 3, we don't care about them. You can place them however you like at si, right? So you can see that your si is only concerned about si minus 1 and si minus 2. We don't care about the letters that were before si minus 2, right? So that's why we can use dp here. As you can see, your dp of I is only concerned about like previous 2 letters. So we can use dp here to go from exponential complexity to linear complexity. Now how can we do this? So let's try to define our dp states. I will again recommend you guys to like see the previous problem. Don't isolate elements. These two problems are really similar, right? So I can define my dp state as dp of I, j and k, right? Here it is the possible number of strings that can be formed up to index I, right? And where your like s of I minus 1 is equal to j and your s of I is equal to k, right? So you can say that your string is ending in j and k. So number of strings that can be formed up to index I ending in letters jk, right? So like that will be my dp state. Now how can I find this? So to find this, I can use dp of I minus 1. to find this. So let's see how we can do this. So we can say your dp of I, j and k, right? This is your like letter at si minus 1, and this is your letter at si minus this is your letter at si, right? So like if we talk about dp of I minus 1, we will have dp of I minus 1. Here let's say it is j dash and here it is k dash. So here your j dash is the letter at like s of I minus 2. So here you will have s of I minus 2, and here your k dash is the letter at si minus 1, right? So you can see that your j and k dash will be equal, right? So you can use your j here, right? You can use your j here. So let's say we use your j here, and let's just call this j dash l, right? So we get j, k and l. So we can use this dp of I minus 1 state to find this dp of I. So we get your dp of I, j, k will come from your dp of I minus 1. Here it is l and here it is j. So we can use this to find your dp of I. So we know the value of index I and I minus 1, but we don't know the value of j, k and l. So we can iterate over these values. So iterate over all values of j. Iterate over all values of k. And also iterate over all values of l. And when you do this, you can say that for your j going from like 0 to 25, right? These are like letters from A to Z. Similarly, for your k going from 0 to 25, for your L going from 0 to 25, make sure that your j is not equal to k and your k is not equal to L and your j is not equal to L, right? Because like if you have 3 letters, like I showed you, if we have si minus 1 and si minus 2, these 3 cannot be same. These 3 cannot be same. So check for that your j is not equal to k, your k is not equal to L, and your j is not equal to L, and update your dp of I, j, k is equal to dp of I, j, k plus the extra base that you just found using dp of I minus 1. So plus dp of I minus 1, L and j, right? So that will be a dp transition. Also one more thing here, it can happen that your letter j is fixed, right? Because your string is something like A, B, C, question mark, D, question mark, right? So you can replace any letter at question mark, right? You can replace anything from A to Z here. But let's say this D, right? This D is fixed. So your S of I has to be equal to D here. There is no other like choice. So you also to check here, like if your like S of I is not a question mark, if your S of I is not a question mark, then you cannot iterate, right? So first of all, check if your like S of I is a question mark or not. If your S of I is a question mark, then only you can iterate over this value of j, right? Then only you can iterate over this value of j. Otherwise, your value of j will be fixed. So before iterating over j, check if your S of I is question mark or not. If it is question mark, then you can go to iterate for j. Otherwise, your value of j will be fixed. Otherwise, your value of j will be equal to S of I, because there is no other option that you can put there, right? So there will be 2 cases here as well. So that will be the kind of pseudocode that you guys will be looking at. Now, like if you guys want to see the code for this, how it all works, here's the code. So I will keep a dp of n plus 1, 28, 28. I will take in my input as my string and my size. I will initialize my dp of 0, 26, 27 as 1. So what I'm doing here is, I'm considering that my string is something like s1, s2, s3, so on up to sn, right? And I'm adding some dummy variables in the beginning, right? So let's say I add, so let's say we have some dummy variables alpha and beta here. So initially I can say that my dp of 0, let's say value of alpha is 26 and value of beta is 27. So I can say that initially dp of 0, right? Here the index is 0, right? So the string ending at 0 with like letter alpha and with letter beta 27 is equal to 1, right? So there is one way to form such a string, and then like I can go on to like iterate over all the other letters. So that is why I'm keeping two dummy variables with value 26 and 27, because all the letters from A to Z will have a value of 0 to 25, right? So I hope that makes sense. So this will be my base case. Then I can go over letters from I up to like n, from like the first letter to the last letter. Then I can iterate over values of j and k. And if j is equal to k, like I told you, right, we have to make sure that your j is not equal to k. Where's pseudocode? Yeah. So we have to check if your j is not equal to k. If it is, we can just like continue, right? We don't want to like think about this case. So if that is the case, we can just continue. Otherwise, we will check if my s of I is a question mark or not, right? If my s of I is not a question mark, then I cannot iterate over the next values. So I will check if my s of I is a question mark or not. If it is not a question mark, the value of this is fixed, right? Value of this is equal to index, that is s of I minus k. So in this case, I will just check if my index is not equal to j and my index is not equal to k. That is the following case. So I will check if my like L is not equal to k and my L is not equal to j as well. Then I will just update the value here, right? Then I will just update my dp of I plus 1 k index is equal to dp of like I j k. So I will update this. Otherwise, if my s of I is a question mark, then I have to iterate over all possible values of si, right? So in this case, I will take a variable L and I will iterate over all possible values of like this letter. So from 0 up to 25, I will check if my j is equal to L or my k is equal to L. Then I will continue. Otherwise, I will update my dp value here, right? So dp of I plus 1 kl is equal to dp of I, j and k. So like you can do this and like this will fill up your dp, and in the end your answer will be what? In the end your answer will be dp of n and all possible ending combinations, right? All possible ending combinations. So that will be A, B, A, C, so on up to Z, right? So you can go over all the possible combinations at the end, and in the beginning you will have dp of n, that is ending at index n or at the last letter. That will be your answer, summation of all these, right? So that will be your entire answer. So here it is, your answer is equal to 0. I will go over all the like possible combinations at the end. J equal to 0, j less than 26. Similarly, k is equal to 0, k is less than 26. Answer is plus equal to dp of n, j and k, right? That will be your entire solution, and then you can just print out the answer. Maybe like my j, k and l, like I showed in the drawing, I think my j, k and l in the drawing are different than what I'm using in the code. So don't be confused, right? Just go through the code once and like try to see the logic is like similar, but I think my variable names are shuffled up in the code, right? So like don't worry about that. The code is like what I explained in the drawing. Only the variable names are shuffled up, right? So that will be the entire solution. And if you guys have some doubts, feel free to ask in the comments or join my Discord server. I'll be more than happy to answer your doubts there. And I will see you guys in the next one. Bye bye.